Okay, so we're back here for part 2 of the notes. So now, we've talked about how you can solve using substitution. I'm going to teach you a different method called elimination. But first, let me show you why elimination might be a better method depending on how the problem is set up. Here's substitution. Here's a system. 4x plus y is 6. That's equation 1. 3x minus y is equal to 1. That's equation 2. Now, to use substitution, I need to first take one of these equations and solve it for a variable. Now, I can do this in equation 1. I can do it with equation 2. I can solve for x. I can solve for y. It doesn't matter. What I do is I look for what I think is the easiest variable to solve for. And in all of these, the positive 1y is what jumps out to me. And here's the reason why. If I take equation 1, 4x plus y equals 6, to get this into y equals, I only have to make one move. I only need to bring the 4x to the other side by subtracting it. Y equals negative 4x plus 6. I have now solved this for y. Now, I don't know the value for x and y, but I can still say I solved it for y. I have it as y equals. If I had tried to solve for x, I would have needed to subtract 1y, and then I would have needed to divide by 4, which also gives me fractions, which, if possible, I try to avoid. So anyway, this is how I'm going to do it. So here's equation 1. I've rewritten it as y equals. Well, for equation 2, I'm going to take this and now substitute it where I see the y. 3x minus the y value equals 1. Okay, that was equation 2. Now, what is the y value? Well, y equals negative 4x plus 6. Now, I do need to be careful here. When I solve this, I have to distribute. I am subtracting both of these. So that's why I wrote the parentheses. I have to distribute negative 1. So this becomes plus 4x minus 6. This is 7x. Combine like terms. Add 6. We get 7x is equal to 7. And then we divide by 7. X equals 1. Now we're not done. We're only halfway there. We found x. Now we need y. Now the easiest place to go back to is the equation where I solved it for y. It's already set up. All I need to do is substitute the number 1 for x. So we get y equals negative 4 times 1 plus 6, and negative 4 plus 6 is 2. So our answer is 1, 2. That is the solution. Does it work? Well, let's plug it in. 4 times 1 is 4 plus 2. Does that give us 6? Check. 3 times 1 is 3 minus 2. Does that give us 1? Check. So there's your answer using what's called substitution. Now, here's elimination. I'm going to rewrite the system. 4x plus y equals 6. 3x minus y is equal to 1. I'm actually going to put the 1y minus 1y. I'll put the coefficient there. You'll see why in a moment. If I told you that x was equal to 10, and if I said that, let's say I multiply both of these by 2, and I say 2x equals 20, and I ask you, is x still equal to 10? If I think of this as a system, have I changed the value of x by multiplying? No, I have not. Something else I can do, what if I add both sides, the left side and the right side of the equation? What's 1x plus 2x? 3x. 10 plus 20 is 30. If I solve that, I still get x is equal to 10. So there are some things here. When you have equations, when you have a system, you are allowed to multiply both sides of an equation by the same value. You are allowed to add the equations, and it doesn't change the value for the variables. So here's what I'm going to do here. Look at this system. So here's equation 1, equation 2. Notice that the y values are opposites. 1y, negative 1y. If I add opposites, I get 0 every time. So if I added these two equations, the y's would cancel out. They would eliminate each other. We would get rid of that variable. So that's exactly what I'm going to do. I'm going to put a plus sign here. And what we do is we're going to add the columns. 4x plus 3x is 7x. Now, what's 1y plus negative 1y? That's 0. That's 0y. So I'm not even going to write that. Equals 6 plus 1 is 7. Now look at that. Now we have one equation, one variable. Now we can solve it. Divide by 7. Oops. X equals 1. Look at how little work we had to do to get x equals 1 versus all of this right here. Now to get the y, I will go back to one of my equations. I'll take the first one because it's with addition. Addition's easier, I think. It was 4x plus y equals 6. The x value, I substitute 1. Subtract the 4, we get y is equal to 2. And look at that, we have the same answer. I prefer elimination when the variables are on the same side of the equation. And what I do is I try to line them up, and if I can, I will eliminate them. The way I eliminate is by adding the equations together. But I add everything. I have to add the x's and the y's and the other side of the equation. As long as I do that, the equality is still true. All right, so let's kind of look at the strategies here for solving systems by elimination. The goal is to eliminate one of the variables by adding the equations together. The coefficients of the variables must be opposites. Positive 1, negative 1, those were the coefficients. And it can be for x as well. It doesn't need to just be y. So what we do is we add the equations, we solve for the other variable, so then we could solve for x, substitute your value into one of the equations, and then solve for the other variable, that was the y, and then check. Okay, so look at number 8. Let's do some examples. Notice that 2x and negative 2x, those are opposites. So here's equation 1, here's equation 2. I'm going to put that plus symbol. That's really important to do that, to remind yourself what you are doing. 2x plus negative 2x is 0. That's gone. 3y plus 5y is 8y. Now this is negative 8 plus negative 24. That is negative 32. See, now we have one equation, one variable, which we can solve by dividing by 8. The y value is negative 4. To get x, we can go back to equation 1 or equation 2. It does not matter. I will take equation 1, which was 2x. I'm always going to rewrite it. 2x plus 3y equals negative 8. That's the equation. Now, I put the parentheses here. What was the value for y? We're going to substitute negative 4. This is minus 12 when I multiply it. Add 12 to both sides. So 2x equals 4. Divide by 2, we get x is equal to 2. So we have our solution. Our solution is 2 comma negative 4. The question, is that correct? Well, let's go back to the equation. So I would do 2 times 2 plus 3 times negative 4. That's 4 minus 12, which is negative 8. Check. It's got to work for both equations, though. So then I would do negative 2 times 2. I'll do it on the side. Plus 5y. That's 5 times negative 4. Negative 4 plus negative 20. Is that equal to negative 24? Check. Okay, now I'm not going to show the check every time, but this is something that you should do. You'll always know whether it's right or wrong by checking. Okay, number 9. Here's equation 1, here's equation 2. Now this time when I look at these, notice that the y's, the coefficients are opposites. Negative 5y, positive 5y. When we add opposites, we get 0. So 2 plus 3, that's 5x. 0y equals negative 20. We can divide, we get x equals negative 4. Now, in this case, I'm going to take equation 2. It doesn't matter. You could put it into equation 1 and get the same answer. 3x, 3 times x, plus 5y equals negative 7. Our x value is negative 4. So that's negative 12 plus 5y is negative 7. We'll add 12 to both sides. 5y equals 5. Divide by 5, y equals 1. Okay, so we've got negative 4 comma 1 looks like the answer. And if I check, I'm just doing this in my head right now, both of these are going to work. Both equations are true. That means this is the solution right there. Now, one thing you need to be careful about is you need to be very clear with your work. If you miss one negative, if you're careless, everything is going to be wrong. It's going to create a chain of effects. You're always going to get the wrong answer. Now, that's why I always check. Because if these don't work, if the equations don't work, I either made a mistake checking or more likely I made a mistake solving. And it's kind of hard to find your mistake with all the work. So my suggestion is get it right the first time. Be systematic, go step by step so that you're not making computation mistakes. Okay, one more here, number 10. In this case, we have A's and B's. The A's are opposites, 3A and negative 3A. When we add opposites, we're going to add them. We eliminate the A's. Those are gone. Negative 2B plus negative 4B is negative 6B. 11 plus negative 5 is 6. We can solve that. We get B equals negative 1. Now to find A, I will go back to the first equation, which was 3A minus 2B equals 11. The B value is negative 1. 3A plus 2 is 11. We'll go minus minus, and we'll divide by 3. A is equal to 3. Now, if it's not x and y, you don't have to write it as an ordered pair. I'll write 3 comma negative 1, and I'll just put A, B here, just to be clear. Okay, again, I would want to check the top equation is going to work, and the bottom equation is going to work, and that is the end of part 2.